All right. All right. Well, there we go. So it is 2 hours UTC, and it's time once again for Astronomy Daily Live. So welcome everybody. Come on in. I'm going to I'm going to open up my chat thing. I've sort of tamed the Nightbot a little bit, so not hopefully not quite as obnoxious. Um, but these Nightbots just sort of do what they're told. So if they're told a different thing, they'll do a different thing. And so we'll see how that all goes. But welcome everybody to Astronomy Daily Live. So come on in, join us. This ever-growing circle of friends gathering together pretty much each and every day to just sort of forget about everything else and focus on the universe. um, and that is what the science of astronomy does. It's I when I was a kid, I was interested in everything. So it's like, okay, well, what do I have to be in order to study everything? And it's like, you got to be an astronomer. And it's like, that's it. That's it. So, all right. So that's what we're going to be doing, sharing the passion, which is the science of astronomy, and getting into it a little bit. Before we get going, Bobby is on the panel once again. Hey there, Bobby.
Hey, what's up, everybody?
Everything okay over there? Still the humidity is way up?
I can go check.
Why don't you go check? He's probably going to do this in the chat, right?
Yeah.
Our Nightbot can tell us our local weather. So there he's just typed in the Nightbot command, my weather, and there it is. So conditions are clear, the temperature at 52 degrees Fahrenheit, the wind is blowing north-northwest 6 miles an hour, and the current humidity is 83%. Holy moly. All right, well.
Let's check your weather.
I'm going to do that. My weather, 85606. Conditions are fair with a temperature of 51. So we're about the same temperature. Wind is blowing from the north-northeast at 5 miles an hour. And the current humidity is, wow, yeah, it is pretty humid today. So 35 is like really humid.
Yeah, now you got jealous whenever last yesterday about the high humidity, and I told you that's joy of living in the slum than in the desert.
Yeah, it's I don't know how you do it, Bobby, but well, if you're happy there, that's all that matters. So very, very cool. All right, everybody coming in here slowly but surely. 80.
Hello, Uncle Bill.
Hey, Uncle Bill. So he says that 83% is not quite way up there. It's just cozy. Uncle Bill, at 83%, I start asphyxiating, right? Because it's like I'm swimming in a pool, right? So, yeah, that'll happen here, like right in the middle of a rainstorm, it'll get that high here. But no, I experienced that over on Maui, right, where it's always about 70, well, between 75 and 85 degrees Fahrenheit, and about the same humidity, right, between 75 and 85. And man, I am telling you, walking around in that is like walking through a pool of water, right? The air is just so just so incredibly thick. So,
Kitty
but yeah,
Kim.
hello there. So yeah, she is she's noticing that I've got the hydrogen hydroxide here, and was just letting me know. Yeah, see, there it is. But you can't have any. No, you cannot have any of that because that's cooties. I don't want any kitty cooties. Uh-uh. But you're free to sit there as long as you want. All right, well, cheers. I've got the
Remember,
hydrogen
you're getting
hydroxide.
HOH as well.
Mm, totally. Totally. No, you cannot have any of
I
this.
think you really got hooked.
You
Maybe
cannot.
if I send you an email of my postal address, maybe you can send me some of that HOH as well.
Well, there's plenty of it everywhere. You just have to have the right connections, all right? But as long as you have the right connections, you should have easy access, easy access. But you got to know the right people. You got to make the right connections, and that's it. All right. Well, cool. So good. Well, I'm glad everybody's doing well. No, no, no. If you're going to do that, you're going to move. There you go. All right. Well, cool. I think I posted over on the Discord some links to some new sounds that I've been making. I've sort of well, I'm trying something else, and that is what I have been doing for a little while is creating these things called binaural beats, and what you basically do is you put uh, one audio frequency in one ear and a slightly different audio frequency in the other, and inside your head, those two are combined. They actually interfere with one another and create a beat pattern, like like a vibrato that has a frequency that is exactly the difference between those two. So if I do like 100 hertz here and 101 hertz here, I will actually hear a 1 hertz vibrato. And the people think
I just I went to your site before, but I never listened to any of the beats before.
okay, yeah, beats. Yeah. So I mean, so what I've been doing is I've actually been creating these binaural beats that change over time. The beat frequency will change over the course of the song, right? And those things change. How those things change is directly related to the motions, in this case, of the 4 Galilean moons of Jupiter. So as they go around Jupiter, they get closer and then further away, closer, further away, and I just convert those distances into frequencies. I can change the units; it doesn't matter what it is, and play it at sort of at one carrier frequency, and then what I can do is I can, with my keyboard over here, I can actually play over that. I can mix something I'm doing on this board with the binaural beats and get what I guess is kind of an interesting sound. So I put a couple of links over on my Discord server to at least a couple of sounds. I was just messing around with a major scale and a minor scale in the same key. It's A major and A minor, and it's kind of interesting how the different scales, and there are literally thousands of different kinds of scales, right? Major and minor are just two. There are 7 primary scales, of which the major and minor are 2, but there are 7 sort of main ones. And then there's just a ton of different ones too, right? I mean, it's amazing what kinds of combinations you can come up with 12 notes in a scale, right? It's pretty amazing. But the number of combinations is almost endless. It's a very, very large number. I think somebody computed that. I don't remember now, but yeah, big number. So yeah, give that a listen, and if you like those kinds of things, I could make that all day, and yeah, each one can be completely different, and like I said, it's based on the motions of the 4 Galilean moons of Jupiter. So, and actually, I can base this beat frequency on anything, right? So, I mean, it can be anything at all. So, I'm just using this is an example. I could use the velocities of those moons. I could use the accelerations of those moons. I could, yeah, I mean, it's pretty limitless in terms of what kind of data I can convert into sound. Now, whether it's interesting or not, I'm not exactly sure. So, difference that I made this time is that I've decided to try playing over the beats, not just having the beats themselves, but actually playing over them in sort of the same key. So I guess it's kind of interesting.
I've never tried those binaural beats with headphones. Is it supposed to be better than speakers?
You definitely need to use headphones. Definitely, 100%. And just a warning though about these beats. They can sort of alter your mental state. So you sort of have to be careful a little bit. If you're listening to these things and you're starting to feel funny, you should probably either stop or evaluate your situation, because they can do that, right? They're tying in to actual brain frequencies, yeah, once you tie into frequencies in your brain, you can do all kinds of interesting things. So yeah, just have to be a little bit careful with these things. And like I said, if they make you feel weird or anything, probably shouldn't do it, right? But try a few of them. I've got a lot of them over there, but they're all just the 2 frequencies. I think I did either 2 or 4. I forget exactly now. I think I did 2. So, I would put the motion of Io in the right ear, and the motion of Ganymede in the left, and then I'd hear the beating between them. So yeah, it's just kind of an interesting thing. Really, really nice if you're into things like meditation or anything. It's really, really nice. It's can be really, really calming. But yeah, so in both of those songs that I posted over on my Bandcamp site, I use the same binaural beats. I just change the scale. I changed the notes I used to play over it. I played it in the same key and everything. I played it in A. Tuned down to 432, right? Instead of A440, I set it to A432, and that's one of those magical frequencies that you know, nobody's supposed to play. So that's why I do it. All right, well, cool. Cheers.
Yeah.
Hey there, Andy. Yeah, you know, they can also be and are used therapeutically in a lot of you know, health modalities and all that kind of stuff. They actually help quite a bit. You sort of got to find things that work. You know, not everything is going to work, but once you find it, it's like you've got it. Good medicine too. So yeah, but you got to be careful. Definitely don't want to freak yourself out, or you know, or you know, these can cause seizures, right? So if you're sort of prone to that, probably shouldn't be listening to these. So yeah, you know, just be careful. It's sort of with everything, right? I mean, with a knife, right? It's like there's certain things that you do and there's certain things that you don't do. And you just have to be responsible. And if you are, then everything's fine and the tool works really, really well. So anyway, so yeah, I'm just sort of mixing a little bit of melody in with the beats. And so the beats are sort of almost in the background now, or at least equally mixed in with the melody. So we'll see. We'll see. I sort of like what I heard there. So, and that's why I put them out. So yeah, we will see. We will see. So, okay, well, you know, what I wanted to do was I wanted to get back to Barnard Star. And there were at least 3 things that I came up with that I would like to try to you know, either see or find out about. The first one is I just want to see what it looks like, right? I don't think that we've actually seen a picture of this thing. I think we saw one in Burnham's, but that was sort of black and white, and you know, you really didn't get a sense of the color. And this is supposedly a red dwarf, so one would expect it to be red, right? So I'd like to see a color picture of it, of this star. And I mean, it's going to look like a star, right? I mean, it's going to look like any other star. The other thing that I'd like to see is a spectrum of it when it isn't flaring, right? Which is most of the time. So I'd like to see an actual spectrum wideband too, right? I mean, if there's you know, as far out into the infrared or radio or whatever, right?
Cosmic, before
Yep.
you continue, I just want to show, speaking of music and binaural beats, I posted Jill's karaoke sessions on the links to Awesome on your server on Discord.
I saw that. Hey there, Uncle Bill. That was a nice try. I liked the response.
Come on.
There you go.
That's a lot better.
Let's see. Uncle Bill, 30625. Weather for Buckhead. Conditions are clear, with the temperature of 46. Ooh. The wind is blowing from the northwest at 4 miles per hour, and the current humidity is 72%. Oh, man, it's like a brick wall. It's like concrete out there. Man, how can you guys stand that?
I don't know, but 72 versus 35 versus 83. Your 35 will make me think I'm dying of thirst all the time.
I that that actually happens, right? You can uh, when you're outside here, especially in the pre-monsoon, so May and June, um, it can be 100 degrees outside. You can walk outside and be working and everything and not sweat. You don't sweat because the air is so dry. It's actually just sucking the water right out of you. So you got to be really
And I
careful.
believe it's just me, you, and Uncle Bill with us. And oh, there's also at least Andy that I know that's
Yeah,
there.
yeah, a a cozy crowd tonight. So no problem. You know these. I'm here to share a passion, and just just by doing it, I'm definitely accomplishing my goal. So yeah,
Well,
if
let's not waste time. Go to Barnard's, would you?
let's do Barnard's. Let's do it. So okay, so I want to see a spectrum, right? I want to see a spectrum. The other thing that I'd like to find out a little bit more about is these flares, right? We looked at one of them. These guys um, were there with a very very high resolution spectrograph, looking for planets, right? And um, you know, I can just imagine, right? You know, they're expecting to see a certain signal, right? A certain amplitude, a certain brightness, right? And they're taking their data,
Uncle
they're taking
Bill
their
Darn, I
data.
spent half of my childhood winters shut in a small room with a
Uh,
vaporizer. Was in a wetter vacation than this.
yeah. I can, wow, I can only imagine. So yeah, you know,
Also,
my
speaking
thing
of
is,
that, I might want to see if I can get like my old hometown.
yeah, I, you know, I'm, I'm not judging at all, right? I'm just having fun with you guys. I think that if you're happy where you are, like as happy as I am, then you're in the greatest place ever. So there you go, Krotz Springs, clear with a temperature of 48 degrees. Wind is blowing from the north at 5. Current humidity is 77%. Yeah. Well, yesterday my humidity was in the teens. It was 13%, which is perfect. Absolutely perfect. Bone dry. Just absolutely bone dry. All right. So those are the three things with Barnard Star that I'd sort of like to look at. So let me get myself set up here, and then I'll share my screen. Let's see. So we're going to go over to Simbad. Simbad has pretty much everything I think that we're looking for. Okay, so here we go. I'm going to share my screen now. Kitty is blocking the light, so it's looking a little dark in here. Okay, hide that. Go over here to Simbad, and we're going to do Barnard Star. I should have already, yeah, because I've already looked for it once, at least once. So let's go to the picture here first. The funny thing is that there's no object on the crosshairs. So this is the first time that we've ever seen that the object that we are looking at or for isn't in the crosshairs. I don't even know if it's close. I think these are much fainter than ninth magnitude. So,
And this is like using what observation window?
What's that?
What observation window you're using?
Oh, you mean the field of view?
Yeah.
Yeah. Well, to a certain extent. I mean, up until now, we've typed in a
Now,
name.
out of my curiosity, can you actually find Barnard stars in stellarium at our current locations?
Absolutely. Yeah. If Uncle Bill wants to do that.
Yeah, hop in the panel, Uncle Bill. We'd like to see a stellarium, please.
Or just post some pictures over on the Discord, or none of the above, because you're probably juggling another 72,000 channels. So do what you can.
All you gotta do is say bye. Give him 5 minutes. He'll be there.
Yep. Okay, so I'm a little confused about this image. So this is Digital Sky Survey 2. Let's look at the Sloan Digital Sky Survey Release 9. There we go. Okay, boys and girls. There, I believe, is, come on, Barnard star. Aha, do you remember our less than sign here? Here it is. Cool, there's a galaxy right there too. So yes, this dude right here is Barnard star. And he's a big, bright red star, right? Not the only one, right? Here's a few others. Maybe either further away or just smaller, right? It's hard to tell. Yeah, but there it is. There's Barnard star. That's cool. It's right next to that really kind of interesting looking galaxy. Looks like there's a foreground star here, maybe. But yeah, that's a nice barred spiral. See, there's a bar right there and the spiral arms. Pretty cool. Oh, and there's another one way back there too. Look at that. There's a lot of stars in this field of view. Oh, we're going to zoom way out here for a second. How far can we zoom out? Filling in the little boxes.
And the biggest dot, the red dot, is Barnard's, right?
Yeah, this guy right here. This guy right there. In fact, let's. I'm going to go back to Burnham's because they have that great map showing
outdated burners.
Good old outdated Burnhams.
Still useful though.
Still incredibly useful. So yeah, let me show you on this little map here where they said it's supposed to be. And so here we go. Right. Supposed to be right about there. Right. So here's our less than sign down here. Do you see this little pattern here that's like a less than sign? So it's going to be north of that, pretty close to this star here, right? Probably not going to see that one. Maybe we will. But yeah, so he's going to be up here somewhere, right? So let's go back and look. These are the kinds of things that I like to do. I sort of like to compare and contrast. See how close the predictions are. So there's supposed to be a big bright star down here, right? I mean, this way is north. So yeah, I'm not quite sure, but anyway, that is definitely right where it's supposed to be, or pretty close. I guess that's probably that's probably that bright star that it was supposed to be next to. So okay, I can buy that. So cool. And yeah, it's just a big bright red star. You can see the diffraction spikes caused by the telescope's optics. Um, and this one sort of has a funky one, right? There's a, yeah, there's, well, there's something funny there. Doesn't look like it's all lined up exactly right, maybe. So this is probably, at least a couple few exposures added up, and they do their best to try to stack them, but
It's not a supernova as of yet, huh?
no, it never will be. These M stars are very, very low mass stars that I think Barnard star is something like a like like one fifth to 1/7 the mass of our sun. So pretty small. So yeah, they'll just eventually burn out, right? They're not really going to do anything at all, at least according to standard theory. Is that these things are just slowly burning out, and no supernova, no nova, no nothing.
In that Aladdin app, that you can actually look at the Gaia data. I was wondering if they have some information about Barnards. I think you told me one time they did.
Oh, I don't know. Let's well, there's Gaia data release 2. Those are all the points that Gaia found. And yeah, I mean, they're doing a pretty good job, right? I don't know if they've exactly located Barnard's star, though, right? That's kind of hard. But looks like they've identified a lot of the other ones. All right, a few of them they sort of miss. Don't exactly know why. It's kind of interesting, that they are missing quite a few, but it depends on signal to noise. It depends on how well things are calibrated. So anyway, yeah, there are the Gaia identified stars. There's a couple of them here and there. See, we can zoom way out, and this thing will just turn totally blue. Okay, I see.
All right, they didn't look at Barnards. I don't know why they didn't see Barnards for some reason.
Well, yeah, it's hard to know if their data was overexposed, then they wouldn't exactly get a really good position, right? It sort of looks like they have a couple of guesses here that are pretty good, right? Hard to tell, though. Hard to tell. Looks like there's an S. See, now if they were smart, that should have been a B, right? B for Barnard star. What's that S doing there? I don't know.
Looks like the S my mom used to draw.
All right, well, cool. So let's go back and go into the papers and see if we can find a paper that has a spectrum. Because I would really like to see a spectrum. And there are observation logs. I don't know what ISO is. Let's just do this. And then we'll just search.
Take a look at some peppers.
Barnards. So we looked at a few of these already. Doppler monitoring a Barnard star.
And I think
Optical.
Uncle Bill is on the chase.
Uncle Bill is on the chase when it comes to locating Barnard's star. All right. Now, how do you pronounce that? Yemasi? Yamasi? And the current humidity is 97%. I would say that's almost that would be like fog, right? All right, well, cool. So I'm going to keep going here. So this is the flare that we looked at, right? But I just want a spectrum of it with no flaring or anything else.
Yeah, he's actually posting the screenshots on the Discord.
Thanks, Uncle Bill. Low-level radial velocity variability in Barnard's star. Secular acceleration, indications for conductive redshift, and planet mass limits. Wow. So, interferometric astrometry of Proxima Centauri and Barnard's star using Hubble Space Telescope Fine Guidance Sensor 3. Hope that looks like the same thing. Study the astrometric motion of Barnard's star. Barnard's star, 20 years of McCormick observations. I don't know what a McCormick observation is. Find out. Go over to the astrophysics data system, and hopefully we'll have a link to a PDF file. We'll find out what a McCormick observation is. Oh, not much. 2 pages. Astrometric data. Wow. Okay. Well, that was basically 1 page.
1 page with no tomatoes.
With no tomatoes. So the results from 24 years of observations of Barnard's star with the Leander McCormick refractor are presented here. All right. Well, they are not presented here by any stretch of the imagination whatsoever. So I think, they probably put them somewhere. I mean, there's a lot of images, 499 images on 143 plates. So yeah, these are still glass photographic plates, but they are definitely not here. So, all right, well, that's the end of that. Let's see this. I'm back. Okay, the astrometric motion of Barnard's star. 20 years of McCormick observation. That's a UV bright star Barnard 29. So that's a different Barnard. High precision photometry.
Yeah, Uncle Bill's gonna try jumping into a couple of months forward to find it in the morning sky. That's
Cool.
on the Discord.
Determinations of the parallaxes of Barnard's star. In 1988, there was a question posed: does Barnard's star have planets? So now that's kind of interesting because, we just found out that Barnard's star does. So what did these guys decide 30 years ago? Can we find out? Kind of cool. Uh-oh. Oh, no. There are no links. There's no abstract. Oh, it was in an astronomy magazine. Oh, I wonder if we can find it. Does Astronomy magazine have like an archive? a free archive. Back issues. Probably have to buy them.
So there's 2 screenshots so far in the Barnard store.
1988. We're honing in on it. Let's see. Volume 16. Which one is volume 16? Oh, I guess all of them are volume 16. Part number 3. Does that mean March? Oh, there it is. Does Barnard Star have planets? Ah, wow. How do we get the rest of it? Digital edition. What's that?
Not clickable?
Well, they are. Let's see.
I'm not sure.
I have no idea. We're gonna find out.
Hope you have to pay for it.
Yeah, we're probably gonna have to.
Looks like you might have to.
Print and digital versions. Digital subscription. Ah, see, they got you. Okay.
Yeah.
So, but here it is, though. Here it is. We actually got it, right? March 1988. Here it is. There it is. It's actually the first featured story, right?
3 screenshots so far on the Discord.
Cool. All right, well, cool. All right, so we're not going to be able to find that one, which is kind of a bummer. Whoop, I'll go back one more.
And here comes the 4th.
Over in Ophiuchus, which, you know, I kept saying was over near Orion, and that's like the complete wrong, the opposite. It's over around Scorpius, Sagittarius, that area. All right, does Barnard Star have planets? Oh, we're going to start at the beginning again. Sorry, we're going to get down here. Whoop, I think we went too far.
Oh, over far. Uh-oh.
Okay, here we go. All right, Barnard Star status report on an intriguing neighbor. Barnard Star once again. The Barnard Star perturbation. The planetary system of Barnard Star, 1982. What? Let's see what this is all about. Let's see if we can. No valid. Oh, no, there it is. Oh. Yeah, no, it's called this weird name magazine. We can't get it. It's too bad. So many misses.
Damn, what a miss.
A lot of misses. Oh, we got to go through all that, a little bit of that again. Barnard Star planets. Our perturbation planetary system, Barnard Star. So they were thinking about planets around Barnard Star at least back to 1982. Here you go. An unsuccessful search for a planetary companion of Barnard Star. So this is in the Astronomical Journal. So, oh yeah, we should definitely be able to pull that paper up. All right, here we go. Eight pages. An unsuccessful search for a planetary companion of Barnard Star.
Okay, Uncle Bill Doran says Sinbad says it's also B2500 OPH and HIP 87937.
Yeah, yeah, it's got a bunch of different names. We looked at that the other day. Okay, so here's the relative positions, proper motions, and parallaxes of 19 stars in the region of Barnard star. Okay, for what it's worth. There's Barnard star itself right there. That big dude with the big 10.27.
And
Yeah,
thank you
cool.
once again, Uncle Bill, for those screenshots and stuff. Those are pretty darn great.
Yeah, that's always very, very awesome. Let's take a quick look, eh? Over there. Let's see. So, let's see. We'll just go through these here. So yeah, there's Ophiuchus. Oh, why is it? Not quite sure why that's that big. Is it supposed to be that big? Not supposed to be quite that big, is it? Oh, now where did I go here? Let's try that again. All right. Well, anyway, here's Ophiuchus. I'm not quite sure. When I do this, it's making it really big. It's not fitting. It's not fitting my screen for some reason. Not quite sure why. Anyway, so yeah, here we are. Here's Sagittarius, right? So there it is. This is okay. So this is.
Make sure you read the text labels I posted with them.
Okay.
With him.
Oh, good. You're probably doing exactly what I am trying to do. So okay, so just after sunset. Yeah, so it's going down, right, for sure. 4 a.m. local time, February 21st. Okay, cool. Anyway, yeah, I just wanted to get a basic location. So yeah, that was really it. This is maybe a little bit better because we can see here's Scorpius, and Sagittarius isn't up yet. So, but it's down here, and Ophiuchus is just above those two constellations, and of course where the crosshair is here. I don't know why it's not fixing this screen. Anywhere, right where the crosshair is there, that's where Barnard star is. Usually the way that I find it, if I'm looking for it, I will I'll try to find these 3 stars and sort of confirm it with this one. All right, so these 3, and then sort of, if you take the distance between this star and go the same distance in the same line, you're going to get really close, and it's going to be the only bright thing there. Well, I guess there's a faint thing right there, but you know, I mean, it's going to be really, really close to that. So that's how I would find it. But yeah, over in Ophiuchus there, very cool. Ophiuchus, I think, was Ophiuchus a constellation of the day? Did we do that? I think so. I don't remember talking a lot about Barnard star though. Maybe I was holding off for now. All right. Well, shoot. I don't think that we are going to. I don't think that we're going to find a spectrum. Shoot, what was this? All the way to the top. Right. Okay, yeah. Yeah, so wow, back in 1973, they were looking for planets around this star. Wow, they've been looking a long time for planets. And we'll just get to the bottom line here. I'm going to zoom out a little bit. This is a little hard to see the right context. All right, here we go. We'll go way to the end where they talk about, results. Let's see, is this all? I don't know if they have it in sections. It doesn't look like they do. They just have. Okay, so let's get to the. So the following are speculations, perhaps idle, on the failure of our data to confirm the perturbation found by Vanderkamp. So somebody found a perturbation.
I think we did do Ophiuchus 3 to 5 weeks ago, but wasn't looking for Barnard stars then.
Yeah. I wonder why I passed that up so quickly. I don't know. Like I said, maybe it's just because I sort of knew that I was going to do this.
Kind of like a bit hit you, huh?
Yeah.
Oh, did you add the constellation command on your Nightbot, or no?
Oh no, I haven't yet. I need to do that. Yeah, that's actually really, really easy to do. So I just need to remember to do it.
What about like solar propagation report?
Working on it. That'll be a longer term thing. I'm gonna have to find a source.
And speaking of it, I think I didn't watch our video yet, but Tim of the Skull says we're probably in the new solar cycle now.
Yeah, I think it's about that time. Yeah, that's how those things go. All right, so let's see. Some of the various disadvantages of using dependencies, work of this type, let's see. We've already mentioned that the metric properties of the optical system of any one telescope may and almost certainly will not remain precisely constant over any extended period of time. Apparently Van de Kamp's perturbation was mostly in the x coordinate, while the proper motion is in declination, so sort of implying the y coordinate. So, well, I don't know. So, yeah, I guess somebody saw some kind of a perturbation, but they're sort of throwing that out. Yeah, so pretty amazing, though. They're going all the way back to 1973, searching for planets. So that's pretty extraordinary. Let's keep going here. Analysis of the perturbations on Barnard star. Okay. Attainable accuracy of reduction to absolute acceleration determined by the long focus photographic astrometry with illustration for Barnard star. Wow. That sounds kind of interesting.
So since when they found out that Barnard star did once have a planet?
Well, up until a week ago, nobody knew. So that's of course it was probably always there, but we're just seeing it for the first time. So they're doing astrometry with photographic plates back in 1963. Wow. So there's an author named Barnard. I wonder if it's the same dude, huh? Must be. Let's we should probably check these out.
I think what's better off if we did check the Wikipedia page, see who was on the first discovered it.
Barnard. Mr. Barnard himself. And here's his paper. Look at that. We can look at the actual paper that he wrote talking about it. So
this is the guy who discovered it, right?
This is the guy that first noticed that it was moving really fast. Yeah. So a letter received at this observatory, which is the Harvard College Observatory, from Professor Henry Norris Russell, director of Princeton University Observatory, contains the following preliminary values of the parallax of a star of a large proper motion in Ophiuchus, which have been determined by him with from micrometric observations communicated by Professor Barnard. So from the differences of the distances of stars A and K, a solution in which the proper motion is eliminated in the usual manner gives a parallax of 0.69 arc seconds. So that's pretty good, right? A parallax of 1 arc second would be a distance of 1 parsec. So since this is less than 1 arc second, it's further away, right? So it's yeah. I don't know how that works out, but that makes complete sense. We know now that it's about 6 light years away, or what, 1.8 parsecs, something like that. Anyway, measures of positives made from the plates of 1894 and 1904, when compared with the measures of 1916, give a proper motion of 10.38 arc seconds, and that's arc seconds per year, towards 355.8 degrees. So that is the position angle. That's which way it's moving. So it's almost due north, right? 360 or 0 degrees is due north. So it's just a little west of north. So assuming this proper motion, the distance measures of the stars AC and K give parallaxes of 0.85, 0.53, and 0.66, and the measures of position angle of mean parallax of 0.75 arc seconds. Cool. So the absolute magnitude of this star is 13.6, and its real brightness is less than 1/3000th that of the sun, making it the faintest star so far known. Cool. So yeah, that was the first report, and so that's November 17th, 1916. Wow, that was just that was like 102 years ago. Holy moly! I think we're all getting old.
Oh, that's sweet.
I like to see this historical stuff, though. It is so cool that we have it all digital, and we can be sitting here, right, on the comfort of our own little porch.
My church that we're supposed to be doing an indexing project that they could go back as to like about the at the close of the 19th century.
Yeah, very cool. So
but
let's look at this one too.
They're running some issues right now, so it's pretty much got suspended as of now.
Yeah. That's a hard thing to do. It's definitely a hard thing to do. Okay, so here's his paper from the Astronomical Journal, right? September 1916. So a small star with large proper motion. The Astronomical Journal, founded by B.A. Gould, number 695. Volume, is that 29? Volume 29? Number 23?
29.
Yeah, I think so. So September 15th, 1916. I have found on my photographs a small star of the 11th photographic magnitude, which has a large proper motion of about 10.3 arc seconds a year.
Now, did Carl Sagan in his Cosmos series did Barnard's star or no?
Did he talk about Barnard's star? I think he mentioned it maybe a couple of times. I don't think he really said much about it. I don't remember exactly, but I think he mentioned it, yes. So he says that the star is yellowish. Kind of interesting. So yeah, here's just all of his measurements, his astrometric measurements. And here's all the calculations trying, to calculate motion over a period of time.
Okay, so Uncle Bill, during that case when stellarium fails to compare to something like Burnham's, I can easily scan for deep sky objects, but a night max star that isn't obviously special does not stand out.
Yeah, very, very true. Very, very true. All right, I don't know what's going on here. Okay, I guess these are just stars in the field of view. The arrow indicates the amount and direction of the annual motion. Okay. I'm not quite sure what P and F are. This is north and south. P and F? I don't know. That's a weird language to me. So yeah, here he is. By comparing this with the position from the visual measures of 1916.423, we get the annual motion of 10.3. In the direction here of 359.7, so almost exactly north. That must have driven him crazy, right? The fact that it was almost straight north. It's like, oh man, that's got to be a telescope problem, right? But no, it turns out that it wasn't. So here's some additional observations, I guess, have been made. 2 other stars not on the chart have been measured. So yeah, they measure the positions of certain things relative to the positions of other stars that hopefully aren't moving, right? So that's what they've done here. They've just identified the positions of a few stars, a few background stars that at least aren't moving at a substantial or noticeable amount. So they stay still while this guy moves. But there's the original paper, and like I said, I think it's absolutely fantastic that that we can view these. Right? This is awesome. It's very awesome. All right. Well, cool. Well, I guess I didn't see any papers that necessarily had any spectra. of Barnard Star. So probably look over on the HST site. So maybe we'll catch that starting tomorrow, because I sort of noticed the time, and I try to be mindful of the time. I don't want to take up too much. I like to spend a good hour if we can. Usually we go over a little bit, like we are now. But, you know, we're doing astronomy here, so time, doesn't matter all that much. But I like to keep a little bit of a track of it. So, yeah, I think for now, let's get out of here. So take care, everybody. I will see you again in a little less than one Earth spin. It's a pretty smooth ride, and so far, it's always arrived, that moment tomorrow. So it probably will again tomorrow as well. So, all right, well, take care, everybody. If you haven't subscribed yet, make sure to do that. Thumbs up, thumbs down, whichever you prefer. I just like to have a reaction. And yeah, I think that's it for now. We'll continue to look at Barnard Star maybe a little bit more, but I think it's time to sort of move on. Time to move on. So we'll do a little bit more maybe with Barnard Star. Like Bobby was saying, look at the Wikipedia page and, see if there's anything else kind of interesting that stands out. I mean, as far as a star goes, it's not incredibly interesting. It's just the fact that it's really, really close and it's moving really, really fast. And that sort of makes it interesting. And now, I guess it makes it a little bit more interesting because there's a planet there, right? So, very, very cool. All right, you guys, I'm going to get out of here. I will see you later. Bye.
Later.